Hi everyone, in this video we are going to discuss the chemistry section of 29th January Shift 2 paper. First we will be discussing the questions of inorganic chemistry, then physical chemistry and then organic chemistry. If we talk about the questions of inorganic chemistry and organic chemistry, they were fairly simple. And the questions of physical chemistry were a bit calculative, but they were simple as well. So let's start the discussion. The first question of inorganic chemistry is, what is the correct IUPAC name of K2MnO4? So if we talk about K2MnO4, first let us determine the oxidation state of Mn. So we can see here, Mn has to be +6 as overall this anionic complex has a charge of 2-. So first we'll write the name of the cation, which is potassium. We do not write dipotassium, but if we talk about this complex, in this complex there are 4 ligands in the form of O2-. So it would be tetra, oxido or oxo, then manganate, and the oxidation state of Mn is 6. Whenever the metal ion is present in anionic complex, we use the word 8. We use the suffix 8. Okay. So fairly simple question from coordination compounds. Next question is directly from DNF block. So if you know this, that the lanthanoids are stable in an oxidation state of +3, you will be able to do this question. You don't need to remember any electronic configuration for this question. So if we talk about cerium, cerium wants to go to +3. So it wants to reduce itself, and if it is reducing itself, it will act as an oxidizing agent. So this is not our answer. GD +3 and TB +3 are already in +3, so they wouldn't want to go anywhere. If we talk about europium, so EU +2 wants to go to EU +3. It will oxidize itself, and if it is oxidizing itself, it will act as a reducing agent. Correct answer is C. Right? A beautiful question from coordination compounds. We know if we have rosy red PPT from nickel, the ligand has to be DMG. In the question they were asking the ligand itself. DMG is basically dimethyl glyoxime, and if it is DMG minus, we usually call it dimethyl glyoximate. It is a didentate ligand or a bidentate ligand, and if we talk about the PPT, the formula of the complex would be NiDMG whole twice. Right? Simple question. Next question is, fluorine has high electronegative in its group. That is correct. Oxygen has least negative electron gain enthalpy in its group. So if we talk about electron gain enthalpy, you must be knowing electron gain enthalpy is the energy absorbed or released during the addition of an electron. But usually it is confusing, so we replace it by electron affinity. I hope you know they are opposite in sign. If this is negative, this is positive. So if we talk about oxygen, sulfur, selenium, tellurium, polonium. Let us just talk about oxygen, sulfur, selenium, tellurium. So what do we see? Usually as we go down the group, electron affinity decreases. Right? But if we talk about the second period, this belongs to second period and this belongs to third period. For p block elements, we have seen that the electron affinity of third period is more than the second period. Right? And if we talk about this family, the electron affinity order is sulfur, selenium, tellurium, and then at the last we have oxygen. If you want to take polonium also, polonium will come here and then we will have oxygen. Right? So this is the order of electron affinity. This is basically, you can say, the magnitude, and oxygen will have the least negative value of electron gain enthalpy as well. So both these statements are correct. Next is a question directly from qualitative analysis. Nestler's reagent. I hope all of you know Nestler's reagent is K2HgI4, and K2HgI4 is a characteristic test of ammonia, or you can say ammonium ion. So basically this reacts with K2HgI4 and we get a beautiful brown PPT of this. This is called as iodide of Milans base. This is a characteristic test of ammonia. Ammonia gives brown precipitate with Nestler's reagent. So the answer would be A. Anyways, the other options are useless only. Which of the following has highest ionization energy? So we have carbon, nitrogen, we have silicon, we have aluminium as well. So if we talk about in a period, if we talk about ionization energy in a period, it increases as we go from left to right, and as we go down, ionization energy decreases. So we know the ionization energy would be highest either for carbon or nitrogen, right? Because second period is better than the third period, and obviously we know nitrogen has higher ionization energy as compared to carbon. And actually if we talk about oxygen also, the order would be boron, carbon, oxygen, and then nitrogen. Nitrogen has unusual ionization energy, unusually high ionization energy due to half-filled configuration, right? There is no option close to nitrogen. A beautiful question again. If we talk about brown ring complex is FeH2O whole 5NO plus 2, or if you want to write sulfate, the sulfate ion is the counter ion. Usually iron is in +2 or +3 oxidation state, but this is a special example. In this we have oxidation state of iron as +1, and the oxidation state of NO is also +1, right? Charge transfer takes place. So the answer would be +1. Next, if we talk about the molecules which have zero dipole moment. So anything which has zero dipole moment is basically non-polar, and usually the molecules which are perfectly symmetric, they would have the value of dipole moment as 0. Let us make the structures. SO2 is not perfectly symmetric. Mu is non-zero, it is polar. CO2 is non-polar, we know that. HF is again non-polar. H2O is like this. It is also polar. NH3, if we talk about, NH3 is polar again. It is not perfectly symmetric. BF3 is perfectly symmetric. It is trigonal planar. If we talk about CH4, it is also perfectly symmetric, right? So it also has dipole moment 0. The correct answer would be 3. So in every shift we are seeing that there is a question of chemical bonding either from hybridization or from dipole moment. Very simple question. Using 2s 2p intermixing, how many anti-bonding orbitals are formed? So if we talk about 2s orbital can only form a sigma bond. So if we have a 2s orbital and 3 2p orbitals we have, but they are saying or we know that 2s orbital basically will interact with one of the 2p orbitals only, because it is going to form a sigma bond, right? So 2s and 2p, only one orbital can interact. These orbitals would be non-bonding orbitals. Now if we talk about the two orbitals 2s and 2p, I will have two cases. I will have a BMO and I will have a ABMO. If you want to name them, you can say this will be sigma sp and this would be sigma star sp. So one bonding and one anti-bonding. So the answer would be one anti-bonding orbital. Right? So that is all about inorganic chemistry. Let's move to physical chemistry. The first question of physical chemistry is from atomic structure, and if we are talking about an hydrogen atom, we know that the Lyman series lies in the UV region. Balmer series lies in the visible region, and anything above Balmer series, be it Paschen, Brackett, Fund, Humphrey, anything, they will lie in IR region. Right? Very easy problem. 50 ml of 0.5 molar oxalic acid is neutralized by 25 ml of NaOH. Then the amount of NaOH in 50 ml of the solution is. So if we talk about oxalic acid is H2C2O4 if it reacts with NaOH, and as you can see it is being perfectly neutralized, so we'll get this. So I can say 2 moles of NaOH are required for this. If I see the millimoles, this is 50 into 0.5, which is 25. If we have 25 millimoles of this, the millimoles of NaOH required are double of that, because for 1 mole we need to have 2 moles of NaOH. For 25 millimoles we'll have to have 50 millimoles of NaOH. So these are millimoles, and this millimoles is basically equal to molarity into volume in ml, and this is basically 50, right? So the molarity I can say is, oh I'm sorry, the question says 25 ml of NaOH. This is neutralized by 25 ml of NaOH, so this is molarity into volume in ml. The volume is basically 25 ml, so through this I can say molarity would be 2 molar. Right? If the molarity is 2 molar and they are asking the amount of NaOH in 50 ml, so the number of moles would be molarity into volume. So molarity is 2 into the volume is 50 ml. So I have 100 millimoles. 100 millimoles is basically equal to 0.1 mole, and 0.1 mole into the molecular mass of NaOH is 23, 124, 40. So we have 4 grams of NaOH in 50 ml of the solution. The correct answer is 4. Enthalpy of vaporization of CCl4 is 30.5 kilojoule per mole. Then the heat required to vaporize 284 gram CCl4 is. Useless question they are asking, no? It says basically for 1 mole we require 30.5. Simple question of unitary method. Just calculate the moles of CCl4. I don't like doing this problem at all. है ना? 284 divided by the molecular mass. If we talk about chlorine, it is 35.5. So that means 4 times of 35.5, 71, 142, 142 and 12 is 154. So these are the moles of CCl4. So you can calculate. I am leaving at this point only. You can calculate for these many moles. The heat required or the energy required would be these many kilojoules. Right? So it says radioactive decay of Br82 isotope has half-life of 36 hours. We know every radioactive decay is first order, and it is given to us that the T half is 36 hours. So we know the value of K or the value of lambda is ln2 by T half, which is 36. They're asking the fraction of remaining particles in one day. So if we talk about another time frame which is t, I know it is 1 by lambda into ln of a naught by at. Now instead of concentration we can talk about the number of particles. Let us say initial number of particles for n naught and the final number of particles are nt. So basically we know t, which is 24, is equal to 1 by lambda, which is ln 2 by 36 into ln of n naught by nt. Right, we need to calculate the value of nt by n naught. They are asking the fractional value. So we can solve for this. Okay, you can solve for this on your own. This value you can use and you can determine the final answer. Next, during electrolysis of AuCl4 minus, current is circulated for 10 minutes and the given mass of cathode, I think given mass at cathode would be this. So the amount of charge circulated during electrolysis is. So if we talk about the gold, so gold is in oxidation state of +3 and at cathode I can see Au +3 with on reaction with 3 electrons will produce Au. So we know the mass, and the mass is basically equal to ZIT, or I can say EIT by 96500. They are asking the charge. You know charge is IT. So the mass is 1.318. The equivalent mass E is basically the molar mass or the atomic mass of gold, which is 197 divided by the n factor. As you can see, the n factor is 3. So this is E into Q divided by 96500. Again, you can do calculations on your own. The value of Q you can easily calculate. Through this, the value of Q will come in coulombs. If you want the value in farad, you can divide the answer by 96500. You'll get the answer in farads. I think in this question the options were in farads, so you can first calculate the value of Q in coulombs and then divide by 96500, or you can directly tell this value, and the answer in farads will basically be 1.318 into 3 by 197. This is the final answer. If I calculate this, 1.3 into 3 is approximately 3.9 something, or close to 4 divided by 197. I think this will come close to 0.02, right? 0.02 farad. The answer would be closer to 0.02 farad. Next question is, in a closed container, equilibrium concentration of NH3, N2 and H2 are this and this respectively. So can you see the type of questions they are asking? N2 and H2 is basically forming NH3. You just need to balance the reaction and you will be done with the question. This is 3 and 2. So the value of Kc would be the concentration of NH3 square divided by N2 square. I am sorry, it will be N2 to the power 1 and H2 to the power 3. Right, so you can calculate the value of Kc. I think this equation was given. If the equation is different, basically if we want 1 mole of NH3, then the reaction would have been different and the value of Kc would also be different. Basically the value would have been the root of this value, right? You can calculate this on your own, right? Very simple problem. The value of Kc has to be calculated. So let's move to organic chemistry. The first question is to match the column. If we talk about starch, cellulose, nucleic acid and proteins. So proteins we know it has to be matched with alpha amino acids, nucleic acids have nucleotides, cellulose has beta D glucose and starch has alpha D glucose. Simple matching. Very easy problem. Next we have phenol, ethanol, para-nitrophenol, meta-nitrophenol, and we have to match them with their pKa values. So we know pKa is inversely proportional to Ka. And if we talk about the acidity, you know phenols are more acidic as compared to alcohols. So if we talk about the Ka order, out of A, C and D, I hope you know OH, other is OH, and meta is basically something like this. So NO2 at para position is basically applying -M, and it would stabilize the conjugate base. So this would be most acidic. NO2 at meta position will just be applying -I, so it would be acidic but not as acidic as the para derivative, and then phenol will come. So basically if we talk about the Ka order, it would be C, then D, then A and then B. So if we talk about the pK order, it would be B, then A, then D, then C. Right, so the highest value is 15.1. So I think B has to be matched with 15.1. Then A would be 10.3. Then D would be 8.3 and then C would be 7.1. So this is matched in this fashion. Let's move to the next question. The correct order of acidity of the following compounds is, again a question of GOC, again a question of acidity. So we need to form the conjugate bases, and if we talk about the conjugate base of CH, triple bond CH, it would be a negative, it would have a negative charge on sp hybridized carbon. Here we'll have a negative charge on sp2 hybridized carbon, and here we'll have a negative charge on sp3 hybridized carbon. Similarly here also we'll have a negative charge on sp3 hybridized carbon. Negative charge is stable on sp hybridized carbon, then sp2. Out of these two sp3 hybridized carbons, since here there is only one donating group, CH3 is a donating group, here there are three CH3, so three donating groups, so it would be least stable. So this molecule would be least acidic as its conjugate base is least stable. So the correct order would be this, right? Next is 2-formyl hexanoic acid. So we have 1, 2, 3, 4, 5, 6 we have COH, and on 2 we have formyl. Formyl basically means CH. So you can count the number of sigma bonds as well as the pi bonds, right? If we talk about the number of sigma bonds, you can see there are 3 here. Then this has 4, 5, pi bonds. I can see pi bonds are just 2, right? The number of sigma bonds would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Sigma is 21. So the total sum is 23. What type of questions JEE Mains is asking nowadays? Which of the following shows geometrical isomerism? So if we talk about geometrical isomerism, we need a double bond, and on one end of the double bond, or I can say on one carbon, the two groups should be different. A and B should be different. Here also we can have A and B, or we can have X or Y. The only thing is the two groups have to be different. Here the groups are same, it cannot show. Here these two groups are same. If I take this group and this group is same, so it cannot show. Here the groups are different, right? This is different and this part is different, so it can show. It can again not show. Very simple question, right? Next is alkyl halides, which is Rx, can be directly converted into RNC. Isocyanide is RNC, and I hope you know we require AgCN for this, and if we want to convert this into RCN, we need KCN. So yes, both these statements are correct. Both of them are correct. Pretty easy question yet again. Which of the following represents correct reaction? So first reaction is NaNO2. I think HCl would be present, right? So in this reaction, if we see, NaNO2 HCl basically produces N2 plus diazonium ion, which converts to CH3, CH2, CH2 plus, and if we have water, this gets converted to propanol, not ethanol, right? This is not the right answer. Next is alkene on reaction with Br2HNu. We know HNu is basically free radical mechanism. So the correct answer has to be a double bond and a bromine like this on the allylic position. Third reaction is the reaction with HI. So we know first a carbocation will be formed, and the carbocation is more stable here, so we'll get this product. Third is the correct reaction. Fourth reaction, if we see, it is Hofmann bromamide. In Hofmann bromamide, the CO is eliminated in the form of K2CO3. A carbon has to decrease, but they are not decreasing the number of carbons. So this is incorrect again. Again, you see in every shift, or I can say every day, they'll ask this question. Riemann-Tiemann reaction, they'll ask every time Riemann-Tiemann reaction. You know, if we start with phenol on reaction with CHCl3 and NOH or KOH or OH minus, basically we get OH, or you can say O minus and CH, right? Finally, if we add H plus, everything will be protonated and we will get salicylaldehyde as the final product. Next is reaction of aniline with NaNO2. I think HCl should also be present. So what we will get? We will get diazonium ion, and then on reaction with CuCl2, chloride ion will replace the N2 plus group and N2 will go away, right? So this is basically Sandmeyer reaction, and the product is chlorobenzene. Next, the IUPAC name, the correct IUPAC name of this is, so if we talk about this molecule, you know OH is a functional group, so numbering has to start from OH, and we need the lowest number for the double bond, so this will be the correct numbering. Sometimes student thinks, no, we'll give priority to double bond. Why we will give priority to double bond? We'll give priority to a functional group. This is wrong numbering. So the name would be cyclohex, or I should not put this, cyclohex 2-ene 1-ol. This is the correct name. Yes, so we are done with this paper. The paper was again pretty easy. The questions of physical chemistry were calculative, but they were easy as well, right? And as you saw that the part of GOC, acidity, basicity part, and if we talk about IUPAC, Isomerism, the questions were very easy.